Hello guys, welcome back to the second week of Learn Programming with Python. In this lecture, we will be talking about Program Development Lifecycle. So let's get right into it. And welcome back to the video. So for this week, we will be talking about Program Development Lifecycle. So you guys might not have encountered this term, but it is actually very essential in the programming life because before we start developing or writing our programs or applications, we need to consider following this procedure. So this is why program development lifecycle is really important. So program development lifecycle technically consists of 4 steps. And for the first one, we have got analysis, and after that we've got design, and when the design stage is finished we can move on to the coding stage, and then finally later on we will be moving on to the testing stage. And each of these stage has their own meaning and their own procedure to carry out. So let's start diving into it. So firstly, I want to talk about analysis. So what analysis does is that before we start producing or developing our program or application, we will have to analyze the program first. So it includes things such as um, finding out the purpose of the program, or finding out if there is any problem with that program. So for the purpose of program, we can think of something like where we want our program to be implemented, or where we want our application to be used. And for the figuring out the problems, if there are any, then we will also have to decide how we can solve the problems. And while doing that, we will also have to consider about the requirements of the program, such as which variables that we will be using, which data types we are going to use, or if the program needs any loops or any conditions, something like that. So while doing that, we can use a method. There is a method called decomposing. So for decomposing is like breaking down the problem into smaller parts. By time when we are writing programs, we might run into some complex problems or a really huge problems. And instead of trying to solve that problem in one go, we can break down the problems into smaller parts, and then we can work on to solve for the smaller parts first, and then eventually we will solve the whole problems. As the problem is broken down into smaller pieces, the process to solve the problem is much more easier than just breaking down the problem in one go. And that is the purpose of decomposing. And moving on, we have got the design. So what I meant by design is not that we will have to make our program look pretty or look aesthetic. It is nothing like that. In this scenario, the design stage is basically providing visual representation of step-by-step process and solution to the problem of the program that we are developing. And the design stage is also important because once the design has been produced, regardless of any programming language that the developer use, they are able to uh, check the design that is produced, and they can work on and develop the program. So there are technically 2 types of designs, and these are no other than flowcharts and pseudocode. And for this week, we are going to be focusing on the flowcharts, and we will leave pseudocode for the coming week's lectures. Okay, so let's move on to the third stage. So for the third stage, Suppose that we have already produced the design of our program, then we need to start implementing our codes. So we need to start writing the codes. And while we do that, we need to consider which language that we need to use. And it is better to use the appropriate language for the appropriate purpose. But for our case, we will be using Python. And let's say that we have already done writing the codes, and we will finally have to test out if our program work or run as it is intended. So it is simple. If we want to do that, we will have to input various type of test data into our program, and we will have to check if the output is correct or not. And there are actually several types of test data, but we are not gonna get into those yet because we are gonna start getting into those once we has written our own programs and problems as well. So as I said, in this week, we will be focusing on design stage. And in particular, we will be talking about flowcharts. So flowcharts are basically a set of diagrams that show step-by-step process of the program. And it consists of various types and various shape of symbols. And we will start getting into those. So first, every program, regardless of their length or their purpose, there is always start and stop. So we are going to use this oval shape symbol. This oval shape symbol is the terminator flowchart, which indicates the start and the stop of the program. Since every program has the start and the stop, this symbol is really essential and it is going to be included in every program that we write. And secondly, we have got the process flowchart. And for this flowchart, we have got two different symbols. One is a single line rectangle, and the other one is double line rectangle. Although both of these shape represent the process of our program, the double line rectangular shape indicates that the process that we will be doing is defined as well, or it is located in other places, or it is already defined. So in our case, we have the process of getting time, meaning that the time is already defined elsewhere and we can get the time from that place. For example, like we can get the time from the clock, something like that. So let's moving on. We have got the input and output flowchart. This shape is actually a parallelogram, and we can use this shape for both when we ask for input from our user or when we want to output the result or just output the word, we can use this symbol. And next, we have got the diamond shape flowchart symbol. This symbol is a decision flowchart symbol. What it does is it checks a condition. So basically in this case, we have declared x and y. So we want to compare if x is greater than y or not. Since this is a conditional statement and it has two optional values, there will be two flow lines going out from this shade. One is for the true and the second one is when the condition is not true. In our case, we have got yes going to the right of the program and no and flowing down to the end of the program. In some case, the flow lines might go back and return to the top of the program, making it a loop. But if it is just a condition, then there won't be any flow lines going back to the top and the program will just end in two different options. So here, lastly, and the most important thing in flowchart is flow lines. They indicate the flow of our program. And I've also included them in this slide as well. For example, in the terminator chart symbol, there is a flow line indicating that our program will start and then it will flow to stop, meaning that our program goes one direction to the stop. And for the decision flow chart symbol, there are two flow lines. The one is when the condition is true, and the other one is when the condition is false. So by checking those flow lines, we can indicate and we can find out the flow of our programs. So as we have talked about the flowcharts, let's review from the previous lecture. From the previous lecture, we tried to print out the word hello world using Python. And this is the visual representation of how the program works. And it is represented using flowchart. Although I have already represented the flowchart of printing out the hello world here, I still want to demonstrate it to you guys using Draw.io because I want you guys to practice using Draw.io. So I'll get there in a minute.